Hey guys, so if you are watching this because you want to learn about the different types of hearts, or because I am forcing you to learn about the different types of hearts. Regardless, you are going to learn about the different types of hearts today. So we're going to start this off with a little review. As always in these videos, I go a little fast. I know that. If you want to write anything down, as you should be writing stuff down, pause, write, continue. But we're going to start off with a little review, so you probably don't need to write this down because you already have it. And we're going to start with looking at a four-chambered heart. Good, that's in the shot. So, we're going to talk about the four-chambered heart as a review. You've already learned this, hopefully, ideally. So, if you remember, four-chambered heart, blood enters through the vena cava. And it enters the right atrium. I'm going to abbreviate RA specifically so that I don't have to keep writing right atrium. So it's in the right atrium. It travels through the tricuspid valve. And when it travels through the tricuspid valve, it enters the... Sorry, I'm going to rewrite this. From body. And it should not be red at this point because it's deoxygenated blood. So, blue marker, deoxygenated blood comes from the body, through the vena cava, into the right atrium, down in to the right ventricle. RV. Then, the deoxygenated blood exits the right ventricle through the pulmonary valve. And it doesn't widen like that, but I'm going to write inside of that. It travels through the pulmonary artery. Remember, pulmonary means lungs. The pulmonary artery is going away from the heart and to the lungs. At the lungs, it picks up oxygen, so that's when we're going to switch from our blue to our red. Picks up oxygen, and it goes through the pulmonary veins into the left atrium, abbreviated LA. And now we are oxygenated. So we're gonna go floop, floop, down here. So it travels through the left atrium, in past the bicuspid valve, into the left ventricle, and then out the aortic valve, which leads to the aorta, which goes to the body, and I'm going to switch that to red. So aortic valve, aorta, to the body. As I said, that is hopefully a review. Hopefully you know that that's clicked by this point, at least ish. But the thing is, this is just the four-chambered heart. There's a lot of different animals. They don't all have a four-chambered heart. Mammals have four-chambered hearts. Birds have four-chambered hearts. that might be it. Just still a lot of animals, but not all the animals. So we're gonna take a pause from this, and then we're gonna go back to this. But we're gonna take a pause from this. So a closed circulatory system versus an open circulatory system. So a closed circulatory system is what we have. All of our blood is enclosed within veins, arteries, capillaries, blood vessels. So enclosed closed system means it's enclosed in veins, arteries, capillaries, etc. If you need to write that down, pause here. As I said, that's what we have. Not every animal has this. For example, insects do not have a closed system. They don't have veins. They don't have arteries. Their blood just kind of goes woo everywhere. Not actually blue everywhere, but they don't have veins and arteries to move it where it needs to go. It just kind of free flows. And we could dive into the science of that, but I'm trying to briefly go over each thing, so we're not going to super dive into that. We're just going to do a minor dive into that and acknowledge that it exists. So, in an open system, there are no blood vessels. Once again, if you need to pause, write it down. I'm going to erase it, so pause, write it down. Cool, I'm going to erase. So, there's open, there's closed. We're going to focus on the closed circulatory systems. The four-chambered heart is an example of a closed circulatory system. Another example of a closed circulatory system is a two-chamber heart. An example of an animal with a two-chamber heart, a fish, like the minnows I have over on my counter. They have a two-chamber heart. So, if I look at my four-chamber heart, I have a right atrium, left atrium, right ventricle, left ventricle. So, if I had to guess, having only one of these, they're just going to have an atrium and a ventricle, which is exactly right. So, blood comes from the body. It goes to the atrium. Body, atrium, ventricle. Where do fish breathe? Their gills. And then back to the body. So, body, atrium, ventricle, gills, back to body. That is a two-chamber heart. Again, pause. So, we have two-chambered hearts, where it goes body, atrium, ventricle, gills, back to body. So, we have a four-chamber heart. Between a two and a four-chamber heart is a three-chambered heart. And there's actually two types of three-chambered hearts, but they're very, very, very similar. So, I'm going to draw my three-chambered heart here. I almost drew a 4-chambered heart. So a 3-chambered heart has the top half the same as our 4, but the bottom half's a little different. So, once again, from the body comes deoxygenated blood into the right atrium. And then our deoxygenated blood flows down into our ventricle. That's right, singular. There is only one ventricle. So, bloop. Floop, I flipped those caps. So there's only one ventricle. So instead of using blue, the blood does mix together. Now it does have methods to keep it from completely mixing, but it does mix some. So I'm going to switch from blue to purple in this ventricle. So the deoxygenated blood goes to the ventricle and mixes with some oxygenated blood. So this mixed blood goes to the lungs. Whoa, not the lugs. Goes to the lungs, which you can mostly see that is what I wrote. At the lungs, it gets its oxygen. Up there. And it goes to the left atrium, LA. Then from the left atrium, it travels down into the ventricle. Once again, mixes with some of that deoxygenated blood. So this mixed blood, up to the body. So it's not quite as efficient as our 4-chambered heart. So pause if you need to write. Awesome. So now I'm going to show our modified 3-chambered heart. Now, some animals that have this type of 3-chambered heart are going to be your amphibians. So, like your frogs, they're going to have a 3-chambered heart like this. The next heart I'm going to show you is going to be our reptiles, so like turtles. So, in a reptile heart, such as a turtle, there's going to be something called a septum. And the septum doesn't go all the way like a chamber does. The wall doesn't go all the way up. It goes part of the way up. And so it does create some divide. So most of the blood over here is going to be oxygenated. And most of the blood over here is going to be deoxygenated. And then there's going to be some mixing in the middle. But it's a little more efficient than in one without a septum. Now, if you forget what a septum is, think of a septum piercing. It's that in your nose, your nostril, it's got that skin. That's basically what it is. It doesn't go all the way to the top. It doesn't completely block off like the 4 chambers. So there's still only 3 chambers. But it helps kind of separate it. It's like a room that has a doorway but no actual door. Like, yeah, it shows that they're 2 separate areas, but like things can still mix and you can go across without having to like break through a door. So that is a 3-chambered heart with a septum. So today we learned about open system versus closed system. Remember, we have an open. Scratch that. We have a closed, insects have an open. we talked about a two-chamber heart. Example, fish have two-chambered hearts, and it goes from the body to the atrium to the ventricle to the gills to the body. Body, atrium, ventricle, gills, body. There we go. Then we talked about the three-chamber heart without a septum, and it has a right atrium, a left atrium, and a singular ventricle. It's been a long day, guys, sorry. Ventricle, singular ventricle. And then we talked about a three-chamber heart with a septum, which is kind of like an in-between step between a four-chamber and a three-chamber. So, again, if you want to write this down or if you want to summarize in words, whatever floats your goat. But I hope you have a super fabulous day.